Hello students, today we'll discuss about what is the force acting on a current carrying conductor placed in a uniform magnetic field. Okay, so see the figure I have drawn here. This is the magnetic field is acting along this x-axis. This is a conductor having length L. Okay, so this is a conductor having length L carrying a current I and placed along this y-axis direction. Okay, so here we have to find out what will be the force experienced by this conductor when we are placing it this uniform magnetic field B. So what we have taken here, let n is the number of electrons present per unit volume of the conductor. So here what we have taken, that small n stands for what? The number of electrons present per unit volume of the conductor. A is the area cross section of the conductor and L is the length of the conductor. Now we know earlier that a charged particle, when it is entering into a uniform magnetic field, it will experience a force. So if you look at this conductor, it is consisting of a number of electrons, which are the charged particles. So that means each electron will experience a force from this uniform magnetic field B. So that means when we'll add them together, so that will be the total force experienced by this conductor. Okay, and that's what we are going to calculate. Now here, first let's calculate what is the force on each electron. Force on each electron will be how much? Let that be taken as small f. So this is the magnetic force actually, so that's Fm. So what will be the value? Formula is what? That is Q V cross B. This is the formula. Q V cross B is the force experienced by the charged particle, and since here we are considering the electron and the electron charge is negative and that is expressed as E, so this is minus E V cross B. Okay, V is what? That is the drift velocity of the electron. So here I am writing, so what is V here? So this is drift velocity of the electron, right? So we got this Fm equals to this one. So this is the force experienced by each, or you can say single electron. But let's find out what is the total that electrons are present throughout the conductor. But for that case, what we need to do, we have to take first current element. So a small current element we'll choose. Let's suppose this is this small current element and whose length equals to what? dl. Okay, so this length is dl. Now we have to first find out what is the total force experienced by this dl, and then we will find out what is the total force experienced by the whole length of the conductor. Okay, so to find that, so first find out what is the total number of electrons we are finding in this small section, because we know one electron experiences this much force. Now let's find out how many number of electrons are present actually in that small section. So here, number of electrons present in elementary section, or you can say in current element dl. Okay, so it will be equals to what? We know what is the number density or number of electrons present per unit volume, so that is n, into what is the volume of that section. So volume of that section will be what? Because its area of cross section is remaining the same, A will remain. What is the length? That is dl. So A dl is the volume of that elementary section. Volume is what? Okay, so this is area into its length. So its area cross section is the same. So area cross section is A. What is the length of this section? dl. So that is giving you the volume. And n stands for what? That is number of electrons per unit volume. So volume unit cancel out. What will be left here? That is the number of electrons. So that's what. So NaDl. Okay, so here I can write here, this is NaDl. So this is the total number of electrons found in that small elementary section. Then let's find out what is the force experienced by this small section. Now, force experienced by current element So here let that be taken as here that DFM. Okay, so DFM will be equals to what? NaDl. Okay, means total number of electrons. Here NaDl, right, into the force experienced by what? One electron. Here this is the total number of electrons present there into the force experienced by what? One electron. So that will be equals to, so this into minus E V cross B. You understood what I have written? So look at here, what this Fm, small fm stands for what? This small fm stands for, that is the force experienced by single electron. Now when we are finding what is the force experienced by the length dl, so here we have already calculated, so in that small elementary length, what is the total number of electrons found? NaDl. Now if one electron gets this much force, so NaDl electron will, they will get how much force? So NaDl into this one. Or this can be written as, if I am taking this minus out here, so minus NaEDl, this is V cross B. Okay. Okay, so here we got this value. Now look at what I said, V stands for what? V stands for the drift velocity. And what is the direction of the drift velocity? Drift velocity's direction is just opposite to the what? That is the current's direction. Okay, so that means here, or you can say the positive charge direction. So this is drift velocity just opposite to the positive charge direction, or you can say the current's direction. So that means here in case of V, I can write down, so V is equals to, that is dl by dt. This is dl by dt because it is velocity. Velocity is what? That is displacement by time. So dl by dt here. What is the displacement here? dl by dt. But here, since it is a current element, and its direction is the direction of the current, so V's direction is always opposite to the direction of the current. So that's why this will be given a negative sign. So V will be equals to minus dl by dt. Okay. Now again you see in this last expression DFM, what is this NaEDl? NaEDl. So actually if you look at this NaDl, that is the what? That is NaDl is the that volume we got. So volume of NaDl is what? Volume of that elementary section here. And this is E stands for what? That is the charge of each electron. Now NaDl, that is the volume into the charge, that will be giving you what? That is the total that charge present over here. So that means in that case this DFM now can be written as, this is minus NaEDl. In place of that I'll write this is dq. Okay, this is in place of V, I'll write this is minus dl by dt cross V. Look at what I have said here. So this, up to this you understood what we have done. This is the total force experienced by this to what current element dl. So see, if I am taking this minus out, this will be plus dq, take this dt out. So inside this is dl cross b. Inside what is there? This is dl cross b. Now what is dq by dt? So that is nothing but what? That is current I. Inside is what? That is dl cross b. Okay. So that means here, that is force which is acting on this small current element what we have chosen. So what is the force value? I dl cross b. Now when we have to integrate, means when we have to find out what is the total force acting on the whole conductor having length L, then we need to do what? That is the integration of this thing. So here the total force acting on the whole conductor, that is Fm, will be equals to what? Integration over dfm. Integration over dfm, or that's equals to integration over I dl cross b. And after integration, this will give you what? I dl integration is what? That is L. So this is L cross b. because V is constant, it will remain like that. I is also constant for a steady flow of current. So only integration will be done for this dl. So dl's integration is what? L, and L is the total length of the conductor what we have taken here. So that's it. This will be IL cross B. So this is your final answer here. So Fm, that is the total force acting on the conductor, is what? That is IL cross B. Okay, so what I can write here, that Fm value what we got here, that's equals to IL cross B. Okay, now or this can be written as this is ILB sine theta, because it's the cross product of these two vectors. So here ILB sine theta. What is theta? Theta is the angle between this L vector and the B vector, right? So this is the thing, means this is the magnitude of this magnetic field. So if you look at the magnitude of this magnetic field, so what is the value? That is ILB sine theta. But if you wanted to find the direction, okay, we can use this Fleming's left hand rule to find out what will be the direction of what? The force acting. So this is applicable, as I said, this is applicable only when theta is 90 degree. Theta is 90 degree, like this picture what I have shown, conductor's length and the magnetic field. If they are making 90 degree, then you can apply your Fleming's left hand rule. Otherwise, you can go for the rule of cross product, or there is another rule is what? That is the right hand palm rule is also there, that also you can use. So anyway, any rule you are convenient with, you can use that rule. Okay, so this is the thing. Now depending upon the theta value, the force can be calculated. So here if I am taking theta to be equals to 0 or 180 degree, then what will be the force acting? Now force acting will be 0, because sine 0, yeah, sine 180 value is how much? That is 0. So that's where the force acting on the conductor will be 0. So that means when so here what we have taken, if theta equals to 0 or 180 degrees, so force acting will be equals to what? 0. So that means when the conductor is either placed what? Parallel to the magnetic field, like that. This is placed parallel, or it is placed anti-parallel to the magnetic field. That means if it will be placed in this way, so that means direction of current is same as your direction of the magnetic field. So this is parallelly placed. If it is placed like this, that means current's direction is opposite to the magnetic field. So that is anti-parallel. So in both the cases, what? Force acting equals to 0. Or you can say the conductor will not experience any force from the field. Now the second case, if theta equals to 90 degree, so in that case, how much the force value? This is sine 90 is 1, so this is ILB. This is the maximum force which will be experienced by the conductor if the conductor is placed at right angles to this magnetic field. Okay, so this is what the expression is. So you need to remember the force experienced by the conductor when it is placed in a uniform magnetic field is what? That is IL cross B. This is what the magnitude part, ILB sine theta.